Thank you for coming to our presentation titled The Effects of Worked Example Formats on Student Learning of Algebra. Worked examples consist of step-by-step derivations of problems and are often provided for students to learn the procedures for solving problems. Research has shown that studying worked examples leads to higher and more efficient learning than practicing problems alone, known as the worked example effect. However, the worked example effect has been primarily shown on traditional worked examples, as seen here, and explained by cognitive load theory and that they reduce students' cognitive load. In this study, we posit that different worked example designs may leverage additional perceptual supports beyond reducing cognitive load to support more efficient learning. New educational technology tools that demonstrate the dynamic process of solving algebraic equations and leverage perceptual supports provide the opportunity to explore the potential benefits of dynamic worked examples. Our main research question is, which worked example presentation leads to the highest post-test score? To study how variations in worked example presentations influence learning, we varied the format of worked example presentations of algebraic equations in an online platform. Specifically, we compare the impact of viewing worked examples in traditional static presentations, sequential line-by-line presentations, and animated dynamic presentations. Within these variations, we also compare concise worked examples, which display only the important steps of solving problems, and extended versions, which display all steps in a derivation. We built an online randomized controlled trial and assessments and online homework platform. A total of 259 students finished the problem set and were included in analyses. The study was designed to be one 60 to 90-minute activity. As students opened the online problem set, they were randomly assigned within assessments to one of our 6 conditions that varied how worked examples were presented. Aside from the worked examples, all participants followed the same procedure. First, students completed an 8-item pretest to assess their algebra knowledge, constructed from open source curricula. Next, students studied 6 pairs of problems. Each problem pair contained a worked example to study, followed by a practice problem to complete. And after completing the 6 rounds of problem-solving practice, students took an 8-item post-test mirroring the structure of the pretest. A paired samples t-test showed that regardless of condition, students improved from pretest to post-test. Next, an ANCOVA controlling for pretest showed no main effective condition, revealing no reliable differences between learning from worked examples with different lengths or dynamic presentation. In summary, the worked example effect seems robust and effective across different types of features and presentations. However, our experimental manipulations were really small and might explain why there were no differences in learning across conditions. Further, in future studies, we will include a control condition to strengthen our findings. These findings are still valuable for the educational research community by providing more evidence that worked examples are effective in online settings. In conclusion, we think that these findings show that worked examples are effective instructional support for online settings. And moving forward, we can continue to explore new ways to design worked examples that leverage dynamic learning technologies. Thank you. I'm happy to answer questions in the live session or through email or Twitter. And thank you to my co-authors, Avery Closser, Jenny Yun-Chen, and Erin Ottmar.